No GPU, no engine, no graphics library. Every pixel of this was written by the processor 1 byte at a time. And all of it's made of this. One address, 1 byte, we build the rest from here. In the next few minutes, we are going to put a word on the screen that nothing printed, then a dot, then a line in another color, then a square. All 5 the same way, and that way is not a graphics library, because there is not going to be one. Today, drawing a pixel is a function call. Underneath that call is an engine, and under the engine a driver, and under the driver a graphics card, and you will never see any of them. DOS has none of that. One program runs at a time and it owns the whole machine. There is no window manager, no driver to ask permission from, and nothing at all standing between your program and the hardware. That is why we are here, and it is not for nostalgia. Machines like this one are still running tills, production lines, and dispatch desks, and this is the only place left where the whole chain is short enough to look at from one end to the other. And the screen turns out not to be a device you send text to. The screen is memory. Write a byte into the right address, and it is on the glass. Now the picture the rest of this lesson leans on. A screen looks like a grid. Memory is not a grid, it is one long row, and the grid only exists because the machine reads that row a line at a time. 0 is the top left corner, not the bottom left, the way every graph you have ever drawn puts it. The top left, because offset 0 is the first byte of the segment, and the first byte has to be drawn first. And it is the top left for an older reason still. The electron beam swept the glass from left to right, dropped a line, and swept again from the top downwards. The bytes are simply in the order the beam needed them, and every canvas since has counted from that corner. So 5 along the top row is offset 5. There is nothing to work out. The row is the memory. 1 row down, though, is a whole width away, 320 bytes, because that is how many the beam drew before it came back to the left edge. And any pixel at all is the two put together, the rows above it, times the width of a row plus the column across. 2 times 320 plus 5 is 645. That one line of arithmetic is the whole of this lesson. Everything after it is the same line again, with different numbers in it. This is a DOS prompt. There is no development environment on this machine, and we are not going to install one. An editor to write the file, and a compiler to turn it into a program, and that is the whole tool chain. The compiler is Open Whatcom. It is free, it is open source, it is still maintained, and it still builds 16-bit programs for this machine. Everything you will see today you can do tonight. The editor is the one built into Volkov Commander because it is already here. Shift F4 makes a new file. A new file, and we will call it memory.c. Before any code, the thing the whole lesson stands on, let us write it down as a comment, because it is worth keeping. 2 screens at 2 addresses. The text one at segment B800, 80 columns, 25 rows, and 2 bytes for every cell, because each character carries its color beside it. And the graphics one at segment 1000, 320 across, 200 down, and 1 byte for each pixel. That byte is the color, 64,000 bytes for the whole picture. Now the part that matters. Neither of them is a grid. Both are one long row of bytes, and the picture is only a grid because the machine reads a line, then the next line under it. So the address of any cell is the row, times the width of a row, plus the column. That single line of arithmetic is the entire lesson. Everything after this is that line, with different numbers. Now the one word in this file that a modern language will not let you say. We need to name those 2 addresses, and on this machine an address is not one number, it is 2. A segment, and an offset inside it. A pointer that only carries the offset can reach whatever segment the program happens to be sitting in, and no further. That is not enough. The screen is somewhere else entirely. So we ask for a far pointer, and far is C admitting out loud that an address here has 2 halves. The high half is the segment, the low half the offset, and the video card lives at 1000. Remember that word. Everything in this series that looks strange later comes back to it. 2 small functions that do nothing but ask the BIOS a question. Each one fills in the processor's registers and fires an interrupt. Interrupt 16 is the keyboard. Function 0 means wait for a key and give it to me. Nothing scrolls, nothing echoes, and that matters, because in a moment the screen will be a picture and an echoed character would push its side. The second one asks the video BIOS for a screen mode. Interrupt 10, function 0, and the mode number in AL. And now the two functions that draw everything in this lesson. Both of them are the line of arithmetic from the comment. Row times 80 plus the column times 2 because every cell is a pair of bytes. And the graphics 1 is the same sentence with smaller words. Row times 320 plus the column 1 byte, no pair because the byte is the color. That is the engine, now the program, and it is shorter than the comment we started with. First, the text screen. 2 words written straight into memory. Watch what does not happen here. Nothing is cleared, and nothing is printed. Then we ask for mode 13 hex, 320 by 200, 256 colors, and 1 byte per pixel. The mode every DOS game you remember was written in. 1 pixel, white, in the middle of the top third. A line is not a new idea. A line is that same call in a loop. The same line again, 15 rows down and 1 number different, and it comes out red. The color is not a name and not a struct. It is a number between 0 and 255. And a square is 4 lines, 2 across, 2 down, and nothing else has been invented. One last thing, and it is not decoration. This program owns the video card. If we leave it in mode 13, DOS comes back to a graphics screen and nothing will put it right for us. That is the program. Save it, leave the editor, and no project file, no make file, no settings dialog. 1 command and 3 switches that are worth. -0 says write instructions and 8086 understands, and nothing newer. -ML is the large memory model, which is what makes far pointers the ordinary kind. And -BCL equals DOS builds a plain DOS program. And run it. There it is, 2 words on a screen that nothing printed to. The DOS prompt above them was not cleared. Because nothing was cleared, we wrote bytes into memory the video card was already reading. Look at the colors. 1F is white on blue, 0E is yellow on black. That second byte in every pair is not a setting somewhere. It is a byte sitting next to the letter. Now a key, and the machine changes mode. 320 by 200. 1 pixel. That is a single byte written to one address, and it is the whole of computer graphics. A line, 200 bytes, one after another in a loop. The same loop, 1 row lower and 1 number different in the color. And a square out of 4 of those loops. Nothing new was learned between the pixel and this. And the screen is handed back, which is the polite half of owning the machine. Everything you just watched was 1 line of arithmetic row, times width, plus column, and 1 word, far, which said that an address here has 2 halves. No library was called. No driver was asked. Nothing stood between the program and the glass, because on this machine there is nothing to stand there. Next time we go 1 layer further down. We write 10 lines of assembly, look at the file it produces 18 bytes, and we will name every one of them, and then change the program with a hex editor without compiling anything.